Alright, so let's get started with MIT Integration B 2025 qualifiers. Okay, so let's get started with question number one. Okay, so question number one. Let me open the question booklet here. So question number one. So the question was to integrate x plus of root x over of 1 plus of root x dot dx. Easiest one, take root x as common, 1 plus of root x over of 1 plus of root x dot dx. So this got cancelled, so we are left with 2 by 3, x to the power 3 by 2 whole plus c. Okay, question number two. Integration e to the power of x plus of 1 over of e to the power of x plus of 1 dot dx. I'll take e to the power of x as t such that the upper e to the power x will get cancelled, so we are left with e plus of t plus of 1 dot dt. So this is equivalent to e ln mod of et, that is e to the power of x plus of 1 plus of c. Question number of 3. So that is cube root of 3 sine x minus of sine 3x. Okay, we know that this could be written as the cube root of 3 sine x 3 sine x minus of sine 3x. That could be written as 3 sine x. I'll use the sine 3x formula. So yeah, sine cube x. So that is 3 sine x minus of 4 sine cube x. So 3 sine x got cancelled, and this minus minus will become plus. So we are left with 4 to the power of 1 by 3. Yeah, integral and sine x dot dx. So 4 to the power of 2 by 3 integral of sine x is minus of cosine x plus of c. Next, so yeah, these are the answers to this question. Next, next is to evaluate the integral from e to the 1 to e to the power of e, that is log of x to the power of log of x base x divided by x square dot dx. All right, so let me write it clearly. So this could be written as x ln x ln x over of, let us write it as ln x. That would be much clearer. Okay, dot dx. Okay, so x and x got cancelled. Okay, let us decrease our screen size here. So 1 to e to the power of e. So integral from 1 to e to the power of e and ln x whole squared x square divided by x square, sorry, x dot dx. Okay, so since I'm seeing the derivative of ln x downside, so I'll take ln x as t. So this could be written as, okay, so ln x as t. So yeah, ln 1 is 0 till ln of e base e. Okay, e to the power of e, yeah, e. So that would be t square by 1 over of x dt over x over of 1 over of x, that is the derivative. So we are left with e to the power of 3 by 3 plus of 0. Yeah, so this is the answer. Okay, yeah, next question. Question number 5. So that is the integral from negative of pi by 2 to pi by 2, that is cosine of 20x sine of 25x dot dx. And okay, so this, since this integral is of form minus of a to a fx dx, we will check the even odd property. So this is even, this is odd, even odd is odd. Since this function, if I'll assume this as fx, then fx would be cosine of 20x sine of 25x, and if I'll take f of minus x, then this would be cosine of 20x sine of 25x, which is equivalent to minus of fx. So this is an odd function. So the answer is directly 0. Why 0? Since this function are exactly symmetric towards the x-axis. Okay, this line. Yeah. Next question. Question number 6. Question number 6 is to, okay, this is the most easiest one. Sin x, cosine x, tan x, secant x, cot x, cosecant x dot dx. This got cancelled. So we are left with 2 pi. Here's the answer. X, so the integral becomes integral x dx. So the answer is 2 pi. Next, question number 7. So yeah, the question that is asking is, we need to evaluate the integral from, not from, but this is a definite integral, that is x log x cosine x minus of sine x divided by x ln x whole squared. dot dx. Actually, this is also ln x, but okay, not an issue. So first of all, I'll simplify it. So I'll be getting cosine x over of ln x minus of integral of sine x over of x ln x whole square. All right. So in this case, what my brain is thinking right now, that I can see the derivative of cosine x as sine x here. So what I'll do is that I'll use the laws of cancellation. So I'll use laws of cancellation. So I'll take 1 over of ln x as equivalent to u and cosine x as equivalent to v. So I'll be getting sine x over of ln x minus of integral of the derivative of 1 over of ln x, that is 1 by of ln x whole squared, right, multiplied by the derivative multiplied by the integral of cosine x, that is sine x dot dx. And if I'll focus it much clearly, then this is exactly positive minus of integral of sine x over of x ln x whole square dot dx. So this and this got cancelled, so we are left with sin x over of ln x plus c, since it's an indefinite integral. Next, is we need to evaluate the integral from 1 to 2 to the power of x divided by 2 plus of log of 2 base log of 2 dot dx. Okay, this is question number 8. Okay, so the integral of a to the power of x dot dx is exactly a to the power of x divided by of ln a. So similarly, 2 to the power of x divided by 2 ln of 2, limit from 1 to 2 plus of log of 2x ln of 2x integral dot dx over of, I'll treat log 2 as constant from 1 to 2. Okay, in this case, I'll take this 2x as equivalent to t. Why I'm taking this as t? Since I am transforming into the standard integral of ln x, and the integral of ln x is x ln x minus of x plus of c. Okay, so 2 to the power of x divided by 2 ln of 2 from 1 to 2 plus of 1 over of ln 2 1 over of log 2. Okay, so 1 half t 2 to 4 ln of t dt. Okay, now this could be written as 3 by 2 ln of 2. After putting the limits, I'm getting this. Okay, so 1 over of ln 2. Okay, half t ln t minus of t, limits from 2 to 4. So in this case, I'm getting there 1 by of 2 ln 2. Okay, yeah, so 1 by of 2 ln 2, and putting the limits, I'm getting this as 4 ln 4 minus of 4 minus of 2 ln 2 minus of 2. Okay, plus of 3 over of 2 ln 2. Okay, 3 over of 2 ln 2 plus of 4 8 ln 2. Okay, minus of 4 minus of 2 ln, this one is 2. Okay, 2 minus of 2. Okay, so let me check that whether I'm doing it right or wrong. Yeah, it's correct. As far as I can see, it's correct. Okay, this one should be 2 plus divided by 2 ln 2, right, divided by 2 ln 2. So okay, basically, if I'll observe this much carefully, then I can notice one pattern, that I'm left with 2 ln 2. This would be 4 and 8, that would be generating 3, right? And minus of 3 and 2, that would be minus of 3 by 2. Okay, so at last I'm left with 3. So the answer is 3. This and this will get cancelled. So we are left with 3. That is 4, 6 by 2. That is 3. Yeah, 3. Next question. Integral from 0 to 1 x to the power of 2024 1 minus of x to the power of 2025 whole to the power 2025 dot dx. Okay, again I'm seeing the n minus of one term there, so I'll take this as t. So if I'll take this as t, then I'll be getting 0 to 1. Okay, x to the power of 2024 t to the power of 2025 dt by minus of 2025 x to the power of 2024, and this got cancelled, so I'm left with was 0 to 1. I'm changing the property, that is a to b minus of fx could be written as b to a of fx, that is the limit changing property. So from here 2025 t to the power of 2025 dot dt, so I'm left with 1 over of 2025 multiplied by 2026. Here's the answer. Next question. Next question. All right, so the next question is to evaluate the integral from 0 to 10 x minus of half x minus of 1 dot dx. Okay, so this could be written as x square minus of half x multiplied by x minus of 1 dot dx. So x cube minus of x square by 2 minus of x square, okay, minus of x square plus of half x dot dx, integral from 0 to 10. So this could be written as x to the power of 4 by 4, and if I'll focus this exactly, then this is um, minus of x square and minus of 3. Okay, so minus of 3 by 2, that would be generating 3 by 2x square. So the integral would be minus of x cube by 2, right? Yeah, so minus of x cube by 2 plus of x square by 4, 0 to 10. So yeah, 10 to the power 4 by 4 minus of 10 to the power 3 by 2 plus of 10 to the power 10 by 4. So 25 500 uh, minus of this is 5000 right? So this would be 2025. Here's the answer. Next question. Question number 11. 0 to 20 integral of the ceiling of the floor of x divided by 2 ceiling x dot dx. Okay, so when x will be running from, okay, so let us write down the expanded form from like 0 to 1, since this function is discontinuous at x belonging to I. If I am talking about the ceiling x function, and it looks like something this, like this much. Yeah, like this. Y is equivalent to floor x. Okay, so yeah, so from 0 to 1, this would be ceiling of 0 by 2 ceiling closed dx plus of, if from 1 to 2, this would be ceiling half dot dx plus of 2 to 3 ceiling 2 over of 2 dx plus of 3 to 4 ceiling 3 over of 2 dx plus of 4 to 5 4 over of 2 ceiling dot dx plus of up till like this, uh, 5 to, not 5 exactly, but yeah, from 18 to 19 ceiling of 18 over of 2 dot dx plus of from 19 to 20 ceiling of 19 over of 2 ceiling close dot dx. So if I'll analyze it much carefully, in that case I'll be seeing one pattern that ceiling of okay, so the ceiling of 0 is equivalent to 0, right? Ceiling of 1.5 is equivalent to 2, the exact next integer in this case. Okay, so this will be from 0 to 1 0 dot dx plus of from 1 to 2 ceiling of half, that is 1, right? 0.5 is 1, that is 1 dot dx plus of 2 to 3, how much? 1 dot dx, again ceiling of 1 is 1, and 3 to 4 2 dot dx plus of 4 to 5 2 dot dx plus of up till from 18 to 19 9 dot dx plus of 18 19 to 20 20 dot dx. Now if I'll observe just a step before, then I'll be seeing from 17 to 18. Okay, ceiling of 17 by 2, 8.5, that is 8.5, right? Yeah, yeah. So 8.5, that is 9. Yeah, 9 dot dx. So we are getting from 18 to 19, 9. So I'm seeing the repetition of each number except the boundaries number, that is 10 or 0. I'm seeing 1 plus 2 plus 3 plus 4 up till 10, right? Multiplied by, not up till 10 but up till 9 multiplied by 2 plus of 10. So n into n plus 1 divided by 2 multiplied by 2 plus of 10, which is equivalent to 100. Done. Next question. I think this one is a very theoretical question, and it's telling to evaluate the integral of the cube root of 3 over of 1 x under the cube root of 4 over of 2 x under the cube root of 5 over of 3 x, right, under the cube root of 6 over of 4 x dot dx, right? So how can I deal with this? If I'll see it carefully, then it's written as x to the power of just the reverse, that is 1 by 3 multiplied by x to the power of, seeing this, then what's it's written 2 by 4 over of 1 by 3 multiplied by x to the power of 2 by 4 1 by 3 2 by 4 3 over of 5 x to the power 1 by 3, or yeah, 1 by 3 2 by 4 3 by 5 4 by 6 and so on. So basically it's forming a pattern in its exponent. Okay, so if I'll see in the exponent, then it's becoming 1 by 3 into 2 over of 4 into 3 plus of 2 into 3 over of 3 into 4. It's something looking like a factorial form, right? But wait, one thing is missing, that is 2. So I'll multiply 2 here, 2 here, 2 here, and to fulfill it, I'll multiply 1, 2 on the upper side also. Now, if I'll observe this carefully, then this is written as x to the power of 2 summation n is equivalent to, let us say, what I can say, yeah, like, okay, 1 till infinity n factorial by n plus of 2 factorial dot, no, there's nothing like integral. Okay, yeah, so integral dot dx. So this could be written as the integral from, oh yeah, so x to the power of 2 sigma n factorial, and n plus of 2 could be written as n plus of 2 multiplied by n plus of 1 multiplied by n factorial. So n factorial got cancelled, n is equivalent to 1 to infinity dot dx. Okay, now if I'll see, then this is written as n is equivalent to 1 to infinity n 1 over of n plus of 2 over of n plus of 1. So let us focus on this. If I'll see the t1 term, the t1 term is actually, okay, wait. This could be further simplified or written as 1 over of n plus of 1 minus of 1 over of n plus of 2. Right, and this is the tnth term. So if I'll see the t1 term, then this would be 1 by 2 minus of 1 by 3. T2 term is basically 1 by 3 minus of 1 by 4. And similarly, tnth term could be written as 1 by of n plus of 1 minus of 1 by of n plus of 2. Okay. So this in this pattern, this all will get cancelled. So we're left with half n minus of 1 by 2. So basically, here at last, I can write this as the integral of x to the power of 2 multiplied by half minus of 1 over of n plus of 2 dot dx. But wait, there's one more thing that is to be noticed. This is actually half minus of limit n tending to infinity 1 over of n plus of 2. Yeah, so it's clearly equivalent to 0. So this is clearly equivalent to 0. So in this case, I'm getting this as the integral of x dx, and this is equivalent to x squared by 2 plus of c. And here's the answer. Next, next is also very much easy. So e to the power of 2x x squared plus of x x x over of x e to the power of x whole square. Okay, whole square could be written as x square e to the power of 2x whole square plus of 1 dot dx. Now, I'll take x square e to the power of 2x as equivalent to t. Okay, so I'll take this as t. Now, e to the power of 2x x square plus of x divided by yeah, so t square plus of 1 dt over of 2x e to the power of 2x plus of x square to e to the power of 2x. Right, so from here e to the power of 2x x square plus of x divided by t square plus of 1 dt over of 2 e to the power of 2x x plus of x square. Cancel, cancel, cancel. So we're left with half integral of 1 over of t square plus of 1. So the answer is dot dt. So half tan inverse of t, which is equivalent to x square e to the power of 2x plus of c. And yeah, here's the answer. Okay, next question. So yeah, next question is integral of sec to the power 4x minus of tan to the power 4x dot dx. Very easy. 40 number. Okay. So as we know that secant square x is equivalent to tan square x plus of 1. That means secant square x minus of tan square x could be written as 0. And using the property a to the power 4 minus b to the power 4 could be written as a square minus of b square plus yeah, multiplied by a square plus of b square. This could be written as sec to the power 2x minus of tan to the power 2x multiplied by sec to the power 2x plus of tan to the power 2x dot dx. Right? Okay, so this got 10 to 1. So we are left with the integral of sec to the power 2x. Okay, and tan to the power 2x itself could be written as sec to the power x minus of 1. That is 2 sec to the power of x minus of 1 dot dx. So this could be written as 2 tan x minus of x plus c. 2 tan x minus of x plus c. Next, integral from 0 to 1 under the root of x multiplied by x minus of 1 dot dx. Okay, there are two methods. One thing is that I can form perfect square and arrange it in the form of x square minus of a square and then apply the formula, and which would be x by 2 under the root of x square minus of a square by 2 ln mod of x plus of under the root of x square minus of a square, right, plus of c. One formula is this, but this would be much lengthy, right? So I'll try direct substitution, that is x is equivalent to sine square theta. Okay, yeah, so x could be written as sine square theta. So from 0 to pi by 2. Okay, And yeah, this could be written as sine theta. Cosine theta, that is 1 minus of cos square theta under root, that is cosine theta. You can neglect mod cause in this case, if you'll see, then when x is running from 0 to 1, in that case sine is always positive. Okay, so yeah, this could be written as the derivative of dx, that is dx could be written as 2 sine square x cos square x d theta, and 2 got there. Okay, yeah, so now using gamma's function, gamma's function, okay, or Wally's formula, I can write the answer as 2 multiplied by, now here's the game, 1 over of 2, 2 plus 2, that is 4, 4 into pi over of 2. Okay, so 2 and 2, okay, so the answer is pi over of 8. And here's the answer. Next question. Again, the same question based on Wally's formula, that is question number 16. So that is sine of 4x cosine of x divided by cosine of 2x sine of x dot dx. Okay, so yeah, this could be written as 2 sine 2x cos 2x, okay, 4 sine x cosine x cosine 2x cosine x over of cosine 2x sin x dot dx. Cosine 2x, cosine 2x got cancelled, so 4 integral of cosine square x dot dx. So 4 integral of 1 minus of sorry, yeah, we are no, 1 plus of cosine 2x dot 2 dot dx, so 2 2, so we are left with 2 into x plus of half sine of 2x plus of c. So the answer could be written as 2x plus of sine of 2x plus of c. Right. Next question. Next question. Integral of sine x sine hyperbolic x dot dx. Now, we know that the integral of sine hyperbolic x is equivalent to cosine hyperbolic x, and the integral of sine hyperbolic x is equivalent to, yeah, dot dx is equivalent to cosine hyperbolic x. Right. Okay. And the integral of cosine hyperbolic x is equivalent to sine hyperbolic x. There's not any issue of minus or plus in case of hyperbolic functions. So I can take this as this whole integral as I, so I could be written as this as u, and let us say this as v. So cosine x, okay, cosine hx, okay, yeah, so cosine hyperbolic x minus of integral of, again, cosine hyper uh, integral of sine x, that is cosine hyperbolic x, and the derivative of, okay, this should be sine x, okay, yeah, so sine x u and cosine hyperbolic x, yeah, so cosine x. Now again, what I'll be doing is that I'll be taking this as let us say, yeah, u, and this as v. So sine x cosine hyperbolic x minus of cosine x sine hyperbolic x sine hyperbolic x sine hyperbolic x minus of the integral of okay, yeah, so plus of the integral of sine x, okay, so yeah, sine x and sine hyperbolic x dot dx. So from here, this is again the same I that we were evaluating there. So 2i could be written as sine x cosine hyperbolic x minus of cosine x sine hyperbolic x. Okay, so I could be written as half sine of hyperbolic x, sorry, half sine of x cosine hyperbolic x minus of cosine x sine of hyperbolic x plus c, maybe. Okay, all right. Next question. Next question. Okay. Next question is to evaluate 0 to pi by 3 sine x cosine of pi by 3 minus of x. I'll multiply 2 upper and both the sides. Why? Because if you'll see then sine of, okay, yeah, so sine of 2 sine a cosine b is written as sine of a plus b plus of sine of a minus of b. So I can write, similarly I can write there as half integral of 0 to pi by 3 and sine of a plus b, that is sine of pi by 3, okay, plus of sine of a minus of b, 2x minus of pi by 3 dot dx, right? So sine of pi by 3, that is sine of 60, that is equivalent to as far as yeah, root 3 by 2, root 3 by 2 plus of minus of half sine of the integral of sine of 2x minus of 3 is minus of half cosine of, the coefficient will come down, so yeah, 0 to pi by 3 from half. Okay, now this could be written as cosine of 0 is if I'll see then cosine of 0, then half root 3 by 2 minus of half cosine of 2 pi, that is pi by 3, okay, half pi by 3, yeah, so half pi by 3 minus of plus, right, minus plus and half cosine of pi by 3, right? So yeah, root 3 by 2 and pi there, pi, so yeah, this and this got cancelled, so we are left with root 3 pi by 4, so this is equivalent to, wait a second, there should be pi by 3, right? Yeah, so pi by 3. So if I'll cancel it out, then we will be left with root 3. So pi over of 4 root 3. Yeah, so here's the answer. Next. Next is to evaluate the integral of cosine x plus of cosine of x plus of 2 pi over of 3 plus of cosine of x minus of 2 over of minus of pi by 3 dot dx. Okay. So Uh, I'm gonna make it much easier. Okay, I'll not directly just integrate it. So what I'll do exactly is that first of all, as we know that cosine of alpha plus beta plus of okay, forget about it. Just cosine of alpha plus of cosine of beta is equivalent to 2 cosine of alpha plus beta by 2 multiplied by cosine of alpha minus of beta by 2. Right. So alpha minus of beta by 2. So from here, I can write it as integral of cosine x plus of 2 cosine of alpha plus beta by 2, that is x. And again, alpha minus of beta by 2, that is cosine of 2 pi by 3, 2 pi by 3 dot dx. Again, cosine of 2 pi by 3 is equivalent to how much? Cosine of 2 pi by 3. This is equivalent to cosine of 120, that is sine of minus of sine of 30, that is minus of half. So this and this got cancelled and we are left with a minus. So cosine x minus of cosine x integral dot dx. So yeah, this is equivalent to 0. So the answer is 0. Done. Next and the last is to evaluate the integral from 0 to 1 summation k is equal to 1 to infinity minus of 1 whole to the power k x to the power of 2k dot dx. All right. So okay. So when I'll open up this sequence or the series, whatever you tell, I'll be getting minus of x square plus of x to the power of 4 minus of x to the power of 6 plus of x to the power of 4. So it's clearly it's a geometric sequence. And we know that the value for the geometric sequence, the sum of value for geometric sequence is the first term. Okay, so this is the first term. The summation of Sn could be written as the first term 1 minus of the common difference r whole to the power of the number of terms divided by 1 minus of r. And when mod of r is less than 1, in that case this formula becomes Sn is equivalent to a divided by 1 minus of r. Now the question is that what's exactly r here? X square. Okay, what's the value of x square? This is ranging from 0 to 1. So clearly one thing is clear, that x is mod of x is in between 1 and this satisfies. So this must be converging somewhere. Okay, so the value or the sum of the net value should be finite. So I can say that this could be written as the first term into 1 minus of the common difference dot dx, integral from 0 to 1 dot dx. So this could be written as minus of 0 to 1 x square plus of 1 minus of 1 over of x square plus of 1 dot dx. So minus of integral of 1 minus of 1, okay, plus of 1 by of x square dot dx from 0 to 1. So minus of 1 plus of tan inverse of x 0 to 1 pi by 4 minus of 1. Why pi by 4? If I'll observe there, then I can get one thing, that is if I'll differentiate it and when I'll add it up. Okay, so tan inverse of 1 is pi by 4. Okay, so our answer is pi by 4 minus of 1. Done. So hope that we enjoy it, and seriously this was very easy. Qualifiers is actually very much easy. The real questions are in the finals. Okay, so yeah, this was the whole solution of this integral. So thank you.